This lesson is on the physics behind music. Let's get started. The goals for this video lesson are to get a basic understanding of the role of physics in music and to see the relationships between the concepts and the equations. Today we're going to talk about two types of instruments. The first type is string instruments. On string instruments, sound is created by vibration on a string. Some string instruments include guitar, violin, and ukulele. The second type we're looking at in this lesson is wind instruments. Sound in wind instruments comes from vibration caused by air. There are two types of wind instruments. The first is open pipe. In open pipe instruments, sound waves enter the pipe through one hole and exit through another. Most wind instruments are open pipe. Specific examples include flute, trumpet, saxophone, and tuba. The second type of wind instruments is closed pipe. In closed pipe instruments, sound waves enter and exit the pipe through the same opening. Some examples of closed pipe instruments include slide whistles, jugs, and organs. In musical terms, the pitch of a note is determined by the frequency of a sound wave. The fundamental frequency is the lowest frequency or pitch an instrument can produce. This is also known as the first harmonic. Any frequency that's a multiple of the fundamental frequency is a harmonic. Basically, to find the frequency of a harmonic, multiply the fundamental frequency by the number of the harmonic you're trying to find. For example, if a fundamental frequency is 110 Hz, the first harmonic would also be 110 Hz, and the second harmonic would be 220 Hz. An overtone is any frequency that is a whole multiple of the fundamental frequency. In other words, an overtone is a tone over the fundamental frequency. For example, if a fundamental frequency is 110 Hz, then the first overtone is 220 Hz. There are two different speed equations because each type of instrument relies on different variables. The speed of a wave on a string is velocity equals the square root of the force of tension divided by the quantity of mass over length. The speed of a wave in air is velocity equals 331.5 plus 0.6 times the temperature of the air. The equation for the frequency of a sound wave is the same for both string instruments and open pipe instruments. This equation is frequency equals the product of the harmonic number times the speed of the wave divided by 2 times the length. On closed pipe instruments, the equation is a little different. Instead of 2 times the length, the denominator is 4 times the length. This is because the wave has to travel 2 times longer than normal in a closed pipe because it has to exit the same way it entered. In this lesson, we learned about two different types of instruments. We learned that harmonics and overtones are really just simple multiplication. We also learned that the equations we use depend upon which type of instrument a problem is referring to.